So we're just talking about polynomials, but we were looking at expressions. Now we're going to move into polynomial functions. So a polynomial function is pretty much just a function in which ordered pairs are determined by evaluating a polynomial. So it's a function made with a polynomial. For example, we frequently use, just to point this out, we usually use P when we're talking about polynomial functions instead of F. So for example, the function P given by P of X equals 3x cubed minus 4x plus 6 is an example of a polynomial function. So like I said, so frequently we use P's for polynomials. Sometimes we use Q's later on. When we start talking about rational functions, then we use a P and a Q. Recall that when two terms have the same variable raised to the same power, they are called like terms or similar terms. And they can be collected or combined using distributive laws by adding and subtracting the coefficients. The sum of two polynomials can be found by writing a plus sign between two polynomials or a subtraction sign between two polynomials, and then we just want to combine like terms. So when we add polynomials, which is what we're doing here, this is one polynomial, this is another one, and I'm just saying I'm going to add them together. So all that really means is that I'm going to combine the like terms. So I get 7x to the fourth. And then we have cubes. So if we add those together, we get minus 2x cubed. Then we have a square, which doesn't have a friend. So we have 4x squared. Then we both have a term with an x. So these are like terms. 6x and 2x will give me 8x. And then my very last one was just those coefficients, not coefficients, sorry, those constants. So we have a 7 and a negative 1. So we get that 6. So all adding polynomials is just going to be adding together like terms. So if the sum of two polynomials is 0, then they are called opposites or additive inverses of each other. So occasionally that could happen. To form the opposite of polynomial, we can think of the distributing the negative sign or multiplying each term of the polynomial by -1 to remove the parentheses. So what we're doing here is we're going to do polynomial subtraction. So here, like I said, we're subtracting polynomials. So to do that, we have one polynomial in parentheses, then we say subtract, and then this would be my other polynomial. This is very similar to adding. We just have that first step of we have to distribute this negative. So if we distribute that across, we're going to get a negative 3x cubed. Negative and plus the x squared is going to give me a negative x squared. Negative times the -5 is going to give me plus 5. Then we just combine like terms again. We get a negative 2x cubed, a negative 5x squared, plus 6x plus 12. So adding and subtracting polynomials is not very complicated. Like I said, it's just combining like terms. And with subtracting, you just have to be careful that you initially have to distribute that negative through the second polynomial. So it's an additive inverse. That's all we're trying to do there. Okay, so take a moment. These are the same two polynomials, just in the first case, you're going to add them, and in the second case, you're going to subtract them. Okay, so for the first one, we just need to find like terms. So we got 4x to the fifth, but we don't have an x to the fifth over here, so it pairs with nothing. We have an x to the fourth here, And we have an x to the fourth here, so these ones are like terms. So 3x to the fourth plus 7x to the fourth is 10x to the fourth. Then we have a negative 5x cubed, but we also have another x cubed, so we have two negative 5x cubes. So those are like terms. If we add those together, we get negative 10x cubed. Then we have this x squared, which once again is like the 4x to the fifth. There's no like term for it, so we just record it. And I know it's tempting to cancel these out, but remember, this is an x to the fourth and an x cubed. They are not like terms. You have to keep them there. You cannot combine them. Now for B, we have that first little step at the beginning where, because I'm doing subtraction, I have to get that negative across. So this is not plus 7x to the fourth, this is minus 7x to the fourth, and plus 5x cubed, and minus x squared. So 4x to the fifth, once again, doesn't have a partner. But my x to the fourths do. I have 3x to the fourth and now minus 7x to the fourth. So it's going to be negative 4x to the fourth. And then nobody really likes this one. We have a negative x, or a negative 5x cubed. And now this is a plus 5x cubed. So these are additive inverses of each other. So they cancel each other out. So that is a term that's just going to disappear now. And then my very last term is the minus x squared.